Good morning, teachers. Now, very few of us in life are tasked with designing entire curricula. Like, I used to work at McGraw-Hill, Rockefeller Center, downtown Manhattan. Well, not downtown, Midtown, Rockefeller Center, you know where it is? Avenue of the Americas. And, I was very impressed even then by, say, the Book of Numbers by Conway and Guy. John H. Conway, famous mathematician of our day, recently passed away. There would be no one at McGraw-Hill who could totally change the curriculum to be something else, right? That would not be possible because of momentum, inertia, expectations. People out there in the field, the teachers, they're not expecting to teach anything greatly different this year than what they taught last year, especially in math. Now, current events may be a little different, so I'm going to talk about ways to access this material, maybe just in a course of not an entire curriculum, but say a lecture or a talk or a YouTube. I'm going to encourage YouTube because then I can see it sometime. Like if you're talking to your kids in Russia or China somewhere, thanks to Owen for that insight into that Russian school on YouTube. If you do it on YouTube, I can see it. Whereas if you're just doing it, not that I'm the key student here, it's just I'm selfish sometimes. So Gibbs phase rule, that was last time we talked about that at some length. We're seeing the whole planet as a system. The biosphere is a system, and it's not a closed system. There are some wrong economics books out there that talk about how Earth is a closed system and entropy is increasing, therefore, because, and blah, blah. But we don't know how to measure entropy at the planetary level. I'm not sure we do, because entropy comes in with, how do we measure order and what difference do humans make in this entropy-entropy equation? And I've queried physicists about this, and they see it as a hot potato. It's not a topic most of them want to take up. That's my impression. Prove me wrong. But I'm saying that the way we look at things in general systems theory it's not about, it could be this way, someday it'll be this way. We want everyone to change the world so that it works the way I describe here. Now, what I'm really trying to do is model existing world. Investments in NGO-style programming in the field and training programs designed to bring competent personnel into voluntary blah, blah. This would be language for what is. It's different language for what is, and that's what makes it more powerful. It's not like, gee, let's have a world like this someday. It's like, here's the world we have, where the sun is kind of like giving a grant to the earth. It's kind of like earth is an appliance plugged into the sun. We're talking about fusion power here. Now, bringing it to planet Earth and running fusion right here on Earth, how necessary is that going to be? A lot of questions about how much energy we need to burn. So there's big picture stuff. And I'm suggesting, as we talked about last time with the Gibbs phase rule and stuff, that we think at that level of entire planets, right? So because right now we're engaged in searching for exoplanets and, where in the galaxy might there be life? And the idea of just simulating planets, sim planet, is a good idea, right? Just in terms of curriculum. So coming into Synergetics and or just our current curriculum through talking about entire planets, not a bad idea, right? And in our case, how does sunlight get converted? How does current become currency? Because what we're getting here is power. What we're getting is power. It's the power that keeps the winds blowing, and I know the moon's involved with gravity. There's lots going on that makes this not a closed system. It makes this more like a nonprofit. We don't have to pay back the energy that we're getting, right? We're plugged into the sun, but it's not like we, the humans, have to treat the sun as a bank that we're going to pay back with interest for all that power. And this is why it's surprising to economists, I guess, that we seem to be getting money from nowhere a lot of the time. Like the money supply keeps growing. What's that all about? And it's like, well, you got to think realistically in a cosmic sense about what the Earth is thermodynamically. Forget economics, think thermodynamics, right? So that's one entry point into mnemonics. And then to be more specific, by mnemonics, I mean a way to think, hold the world together in your mind, just to keep things organized, right? It's like memory palace, like people used to do if they had positions of management in the old days before like computers, they'd treat their head more as a spatial data management system, and they'd actually get trained to do that. You had some amazing people out there, and then they build furniture to help remember stuff, you know. But the methane issue, that would be a case of like Gibbs phase rule. If we trigger a melt of methane, by we, I mean we, the global warmers, you know, if the carbon dioxide is sufficient to change the physics so that it's like when you open a bottle of a soft drink or pop. Why it's even called pop is the cap pops off and then it fizzes, right? The bubbles suddenly coming out of solution because of sudden release and pressure. And, you know, if the temperature goes up, that could be another thing that releases, right, bubbles. It could fizz methane in the Arctic region and thereby change the atmosphere again towards greenhouse, where we become much more, the heat doesn't get out as quickly and so forth, right? Now, this related fact check article, that's Facebook adding that. I'll have to take a look. There's something in The Guardian I should read, it says. Okay, so we've got global warming, global climate change, and economics, ecosystemics. And I go out on Facebook and talk to the ecological or the ecosystem people. What's it called? Ecosystem, what's it called? Systems thinking, systems, blah, blah, blah. Here we go. The ecology of systems thinking. This is probably where I get some of my free consulting, you could say, because I'm an optimized little organization, Oregon Curriculum Network here in Oregon, just a little, you know, Portland is a little jewel on the Pacific Rim here. And a lot of these folks are in Europe and stuff, but they have big picture, you know, diagramming going, and they're definitely at the curriculum level designing. So I come here and get free consulting about, you know, how to network, who to network with, and then filter out these ideas. Now, a third filter out by osmosis. By filter out, I mean allow it to trickle out and make it more amenable to trickling out, right? Chemically, like more useful to people, right? And organize your head with this stuff, right? Help yourself with Conway and Guy. You do figure it numbers, right? Triangular numbers, square numbers. So suddenly it's kind of like a math class, but you need to do simple computer programming, like 1 or 2 line programs to generate these sequences. And then all of a sudden you jump to polyhedral numbers as opposed to figure numbers, such as the growing cuboctahedron of the CCP, what we use for the tensegrity lattice, or flextegrity, I should say, by Sam Lanahan here. Lots of videos on those experiments and art projects. And so the jitterbug here, you could say, well, this is just a mnemonic device, you could say, right? It helps you link this CCP kind of symmetry to the icosahedron fivefold symmetry. And the numbers are the same. The balls don't change in the outer shell when you do this little distortion, which is why the cube octahedral numbers are the same as the icosahedral numbers. And there you get 112, 42, 92. Now that's all over the place in Synergetics. And you'll see as we scroll down here occasional mentions of Buckminster Fuller a couple times. And as you get further down into the link section, you jump to the virus page at my website where I talk about the geometry of the nucleocapsid, the nuclear sheath, if it's an icosahedron. Now, in the case of coronavirus, the COVID-19 inducing virus, doesn't have a nucleocapsid that's an icosahedron. Herpes does. A lot of viruses do. And it was a breakthrough in synergetics to discover this, right? Discover the icosahedral symmetry of viruses. And this helped with the later kind of moving on to quasi-crystals, because the virus is very crystalline. And yet here was all this fivefold symmetry. So quasi-crystals could be another topic that leads you into this curriculum. And again, it could be at the lecture level. And then finally, if you're into what I'll call spy literature, it's a genre, right? I've been talking American Transcendentalism, but what's the overlap? The character Angleton. I never know if I should say Angelton or Angleton. I think Angelton, how about? No, that doesn't sound right. Angleton. So we can figure that out another time. Applewhite, the collaborator on Synergetics, in this story on The Intercept, How the CIA Writes History, he's getting the runaround on accessing Applewhite's collection of Angleton's letters. There's more to, he just, like, they're not ready for him to read that. And so you've got Applewhite. And this again is linking well, and you've got Angleton. And I've got Graphing the Poets, another video where we talk about his relationship with Ezra Pound early in life. And I think that would have something to do with, this thing isn't charging, I just noticed. Hold on. Let me re-plug in this computer. I'm down to 10%. There we go. I think Ezra Pound probably got cushier room and board at the mental hospital after they captured him and brought him back, put him in a cage, brought him back to DC for trial. He ended up in a mental hospital for like 10 years, but it was not that bad. He could have guests and hold forth, be taken care of, sort of poet in residence. And maybe Angleton had something to do with that, I speculate, because of earlier connections in Italy, right? But I don't know this. I'm just speculating. And I'm just saying there's a lot of ways in to synergetics. And once you get in, it's kind of like a microcosm. I'm showing you a metaphor for a microcosm. Like Zoltar here, right? He's in a bubble. He's in a bubble. And that's what you do when you create a system. You see the world through your system. It's kind of like being Zoltar in a bubble. And in the synergetics informed system, we use the cube less and the right angle less. So the books in our syllabus tend to be of interest to architects, and this is where Fuller, the dome guy, comes in. And that's a beaten path. In other words, we've had the dome connection all this time, and yet still your average sixth grader knows nothing about how A modules make the tetrahedron, and they've never gotten into this is good for a work process. Like divide the kids up, have some fold left, some fold right. Let the kids design their own workflow. Make a song out of it like you do in Africa or something. In other words, it's not just about each kid building one of these. It could be about, like when we did it at Winter Haven, the whole sixth grade built this rather quickly because you had a lot of kids, right? And then it becomes something that they all have, right? In the classroom setting, it's not like every kid takes one home necessarily. You're not cluttering up the personal workspace necessarily when you do this kind of thing. So, Poland, they have a lot of interest in the Bucky Fuller memes. Here's the play by D.W. Jacobs in Polish. He's over there doing it in Polish not that long ago, actually, before the outbreak of COVID. So, multiple ways in, and once you're in, you've got this concentric hierarchy that's interesting and useful, right? Because you've got your CCP, like we talked about before, space filling, sphere packing. Not that it's density about 0.74. And then you've got these polyhedra with the rational whole number relationships, which in terms of memorizing and just keeping them in your head and being a designer who knows your polyhedra because you learned it in sixth grade the Bucky way, right? You're grateful for that. You're looking back thinking, gosh, what a disorganized kind of hodgepodge they had. People think my lectures are disorganized, but if you've listened long enough now, you realize you've never heard anything this organized, probably, right? All right, so spreading, going around the world, putting a Quaker brand on it, and working with the Russians because of grid talk, right? We've had the California grid story, now the Texas grid story. More grid talk is good. I'm glad. It's looking promising. All right. Talk to you later.